In the basic course, we talked about constant local variables. These variables must be set when we declare them and cannot be changed later in the program. Similarly, because the field is a variable declared inside the class, we have the option to make it a constant. In simple terms, constant fields and locals are not like regular variables because we can change their values. In this lecture, we'll explain what a constant field is and how we can declare a field as constant. Hello guys, welcome again. Okay, a constant field is a field that holds a value that cannot be changed while the program is running. Let's understand constant fields with an example. First, we create a class called Circle. Next, we declare a method named CalculateArea. Okay, to calculate the area, we need to multiply the value of pi by the square of the radius. So, we declare a private field called radius to store the radius value. Then, we create a property with the same name as the field. In the getAccessor, we check if the radius is greater than 0. If it's not, we return 0 instead of the actual value. In the setAccessor, we also check if the value is greater than 0. If it's not, we display an error message. Alright, now let's declare a field to store the value of pi number. Next, let's return the area of the circle by multiplying pi with the square of the radius. Now, let's go to the program class and create 3 instances of the circle class. After that, we print the calculated area for each circle. Finally, we run the application. As you can see, for each circle, we get the corresponding area value. Alright, let's talk about the pi value. In this case, pi is always constant and cannot be changed. This means that for all instances of this class, the pi value remains the same and never changes. However, with this current implementation, we can easily change the pi value. For example, in this method, we can change the pi number to whatever we want. Even if we make the pi field read-only, we can still change its value in the constructor. Now, let's run the application to see what happens. As you can see, we're getting unexpected results. To solve this issue, we can use the const keyword for the pi field. Const fields are great because they stop values from being accidentally changed when we know they should stay the same throughout the program. It's important to note that a const field can only be initialized at the declaration of the field. Alright, when we mark this field as a const field, we cannot change its value, not even in the constructor. If we try to do so, like here, we'll encounter an error. Okay, if we wanna to use a const field only within the class, we can make it private, just like the pi number in our example. However, we can also make it public and use it outside of the class. Depending on the situation, we can choose any of the 6 access modifiers we want. Alright, the naming convention for const fields is to use screaming snake case, so let's change it accordingly. Okay, one last thing you should know is that const fields can only hold numbers, boolean values, strings, or a null reference. Okay, done. See you soon.